work up to this point has been on classification. So classification, remember that the input variables that you have are called features, and the thing that you actually want to predict is called the target. So this is why when we do features, when we split our data frame into two things, we have X and then we have the target, which is what you're trying to predict, the output, and we use Y for that. And this is intended to make you think of Y equals F of X. And your job is to build this F. Type of the target is, it changes what we call it. So if the target is a class, which means a small finite number of things it could be, this is a classification problem. Now, ordinarily what happens is your class starts out as not a number. It starts out as something like a species of penguin, or a biological sex that you're trying to predict, or whether or not someone graduated college. And then you convert it into 0 and 1. But the point is there are only a few things it ends up being, and they're separated. You can't talk about there being like infinitely many distinct values that it could take. Whereas if what you're looking at is a continuous numerical variable, you're looking at what's called regression. Now, what's weird is we saw an algorithm, we saw a type of machine learning model earlier called logistic regression. We actually used it for classification. That's a little bit disorienting. Regression is the type of thing that you use when you want to predict something that could take essentially any numerical value in a certain range. So one example of a regression problem would be if you are trying to predict the price of a house. Actually, a classic one. There are several cities which are, but that would be an example of a regression problem, because you can't say, well, it's either going to be $10,000, $100,000, or $200,000. It can take any value. And you could also look at predicting energy usage, thing that's common now. So you're allowed to have things that sort of might like housing prices, you only go to the hundredths of a cent. But the point is, it's not a small finite set of things you're trying to predict. And I'm sure you can think of lots more, but you're not doing classification anymore. The nice thing is, from like just a pure hacking at sklearn perspective, if you understood and have a good sense of how to do classification, like the pure process of building the code that will build one of these things, it translates very nicely to regression. So almost every model that we've worked with, or even that you see, has a regression version and a classification version. Remember that we have worked with decision tree classifiers in the past. Well, there's also a decision tree regressor. And so all you have to do is go look at the library, the page for decision tree regressor, and guess what? The process of building a decision tree regressor model in sklearn is exactly the same as the process of building a decision tree classifier. It has a fit method, it has a predict method, and it has a score method. You're still going to take your training data and your testing data, call .fit on the training data, call .predict on individual observations, or .score on the testing data. Are you doing classification or regression? Because those are two very different things. And if you are trying to do classification and you're using a regressor or vice versa, it's going to be a disaster. Not only will it be a disaster in the sense that your model doesn't work, it'll be a disaster in the sense that if anyone comes along and looks at what you've done and they know what's happening, they'll think you don't know what you're doing.